Hello everyone, I am Satish Kumar from VIT University, Chennai, pursuing MTech, first year Mechatronics. Here, I want to present a video lecture on blind spot monitor sensor. From this video lecture, we can know that what is meant by sensor, blind spot monitor sensor, and where it is applicable. Through here, the whole lecture will contains introduction part where we can discuss sensor and all this and its types and from where its working condition and history of sensor and history of blind spot monitoring sensor and why we are using sensor, what are the problems before that, and for the solution and working of the blind spot monitoring sensor and its advantages and disadvantages, and finally conclusion. Introduction. In highways, there are many different lanes. From 2 lanes to 6 lanes are available. In each lane, cars will go. By changing lanes on its busy highway, it is very dangerous. So every car has a blind spot that are not covered by the driver's mirrors. Left side and right side mirrors are available, but we cannot see the backside cars what are crossing our car. Relying solely on the mirrors while changing lane can lead to a collision with another vehicle. So to avoid this, the blind spot monitoring sensor is implemented to alert the driver First of all, before this, we have to know what is meant by sensor. A sensor is a device that detects events of changes in quantities and provides a corresponding output, generally as an electrical or an optical signal. It provides any type of signal. First, it receives and gives appropriate function. In sensor, there is a smart sensor which is known as, generally sensor comes with signal conditioning, which is called as integrated sensor. With this integrated sensor, when we attach the microcontroller, together microcontroller and integrated sensor is called as a smart sensor. Why we are calling this smart sensor is, microcontroller is an automatic. We can give program to run the function automatically. So we are calling this as a smart sensor. Sensor sensitivity indicates how much the sensor output changes when the input quantity measured. It is defined as the ratio between output and measured property. To be a good sensor, the 3 rules have to be obeyed. One is, the sensor have to measure properly. The sensor have to measure input properly, and it does not influence measured property, and is insensitive to any other property to its surroundings. It does not depend on surroundings. Now, working of sensor. In working, sensors firstly respond to sensitivity of the respective changes. Means, it will first observe what are the conditions in the environment. All sensors works basically by converting the one type of signal to other type. Every sensor do same work, converts from one form of energy to another form of energy, but it depends on what type of work in the environment. and this is done mainly by transducers, which helps to attain the desired output signal form. The transducer is the main purpose for converting one form of energy to another form. So this is called as transducer. Sensor working in flowchart. Here you can see the flowchart of sensor. From here, plant. Plant it consists of robot, autonomous guided vehicle, numerical control machine value, vehicle engines, conveyor system, consumer products. Which means this is the main source which is given the input to the sensor. These are the parameter variables collected. The sensor will receive the parameter variables from the plant, and it sends and gives the signals to the signal processing. Here, signal processing means the signals will be processed from sensor to microcontroller by amplifying. Here, in microprocessor, the processing unit consists of microprocessor and microcontroller known as control code. In this microcontroller, it controls according to program which is designed by programmer. After controlling required inputs according to microcontroller, the command signal will send to actuator, which is actuated by command signal, and this actuator actuates and sends the output signal to the object. This is the total sensor will work based on this basic principle. M types. There are many types of sensors depending upon environment and their application. Some of the types of sensors are acoustic sound vibration sensor, automated sensor, transportation sensor, chemical sensor, environment, weather, moisture, humidity sensor, based on position, angle, displacement, optical light sensor, imaging sensor, force pressure sensor, density level sensor, thermal sensor, heat and temperature sensor. Out of these, the blind spot monitor sensor comes under automotive sensor, which is used in automotive field. Blind spot monitor sensor. It is an automotive sensor which works on the principle of radar sensor. The main basic principle for this application is radar sensor, and it is also not depends on only its radar sensor. It is also depends on ultrasonic sensor and real-time imaging process. These rays you are observing here in this slide is the car producing a radar waves in certain range. Blind spot monitor sensor. It is designed to alert the driver to the presence of vehicle in blind spot area of adjacent lane. What is meant by blind spot? The meaning of blind spot we will discuss in later slides. Blind spots are the areas on both sides and rearward of a vehicle not visible within the rear view or door mirrors. The vehicles are crossing from rear. The vehicles are overtaking from our car. But where it is located and we are not visible is called blind spot. It is as simple as using convex mirror, but electronically. Normally we will use before blind spot, convex mirrors are used. Same application we are applying electronically. History of sensor. History of blind spot monitor sensor. This method was first revealed by George Blatcher. In 1925, a paper was presented to the Society of Automotive Engineers. And for this paper, he received a patent for the blind spot monitor sensor. And it has been incorporated into various products associated with Ford Motor Company. This is the first automotive company which which uses the blind spot monitor sensor in application. This system was introduced on the redesigned 2007 Volvo satish sedan and produced a visible alert when a car entered the blind spot. Normally, the Ford company started with giving alert to the driver, whereas in Volvo SAT, they produce an visible alert whenever object is entered into a blind spot. The rapid increasing of vehicles, road safety becomes a significant issue around the world. Due to this cause, accidents, car accident, and unsafe lane changes takes place an important role. The vehicle blind spot monitor method and system helping the driver of a vehicle to detect the objects within a predefined perimeter of said vehicle. Means, in blind spot monitor sensor, we can maintain a minimum range to observe blind spot alert. Whenever the object is entered into the blind spot area, it will alert the driver and indicates you have to change the lane or you have to stay there itself. The purpose is to detect and monitor objects within a predetermined distance from the vehicle that may be encroaching its blind spot. The method and system utilizes before using blind spot, the system utilizes ultrasonic sonar sensors detectors for the vehicle to detect approaching objects, including other vehicles. Just it will detect approaching vehicles but does not. It indicates signal to the driver. In blind spot monitor sensor, it indicates the signals to the driver. That is the main application of this sensor. Before using blind spot monitor sensor, what is the problem occurred in lane changing? Before using blind monitor sensor, we are using convex mirrors. In left hand side view mirrors, we are using mirrors for viewing lanes while crossing the roads. This is the main reason for failure of traditional rear view mirrors. What is meant by convex mirror? If rays of light are carrying the image of a car in a mirror and those rays travel outward before hitting your eye, the car that reaches your eye is not exactly the same as the car that reflected the light. To be more specific, it's not in the exact same location. The light travels in the concave mirror is not exact one. The object we are viewing is located somewhere and we are transferring this object very near through convex mirror. To our eye, the image carried in light reflected from a curved surface appears to be located where those light waves intersect. This is the focal point. Whenever the light rays passes and reflects to the nearer point, to our viewpoint, the viewpoint is called as a focal point. That's why, if you observe or not, in convex mirror, object is in somewhere at distance, but while seeing in convex mirror, to match our to match the focal point, it will appears very nearer. Like this, the light rays reflects to our focal point. Reflects to our focal point. Here you can observe in video what is meant by convex mirror and how blind spot occurs. Where is the blind spot and all these things. This is called convex mirror. If you observe the video, the object is somewhere, but we can, to match our focal point, the convex mirrors are designed like this. The object, this space is called, the car is somewhere crossing, but we are visible in this very nearer. And what is meant by blind spot? Here, the red zone is called blind spot zone, and the green zone is called normal viewpoint of left side, right side view mirrors, and rear is called rear view mirror, and rear is called rear view mirror. Whenever the object enters into red zone, it is not visible to us. We cannot visible through our normal view mirror, but we can view through this convex mirror, but it is not alerting signal. Just we have to check it while crossing the lane. We have to check this mirror and then we have to go. This is the problem of failure of mirrors, and it does not alert doesn't show any indication. While seeing this mirror and if we change our lane, means definitely we can collide opposite vehicles. And this is the green view is called normal view through side view mirrors. To overcome this problem, we are implementing a blind spot monitoring sensor. This is the solution for this, to avoid accidents in highways while crossing lanes or overtaking. Here you can observe that here blind spot visible, and it indicates through indicator or through audible voice. What is the blind spot sensor? Features of blind spot monitoring sensor. The blind spot object detection may have different names depending on the vehicle makers. These are already in application and used in some automotive companies, and some of cars are Audi calls as system side assist, and Mercedes-Benz is called as the blind spot monitoring, and Volvo called as blind spot information system. Depending on the vehicle makers, these systems may use radar sensor, which is called as blind spot image detection, or cameras. And the working, I already discussed with these are used with radar sensor or image real-time image processing. First, we will see what is the working with radar sensor and what is the application behind in this, and its advantages and its history, and all these things we can see after this slide. First we have to know what is meant by radar sensor. Radar is an object detection system that uses radio waves to determine the range, altitude, direction, or speed of the objects. There are different types of range detections. Radar sensors are available, which will calculate. One is range, to calculate range, or to calculate altitude from flight to slope, to calculate direction, or to calculate the speed of the object. And it can also be used to detect aircraft, ships, location of ship within the range, and the location of spacecraft, guided missiles, motor vehicles, weather information, and terrain. And this is called radar sensor, which produce radio waves. The working of the radar sensor we can see later slides. And here we can know that what is the principle behind the radar sensor. Radar systems are composed of a transmitter that radiates electromagnetic waves of a particular waveform, and there is a receiver that detects the echoes returned from the target. It will give radio waves up to certain range. Whenever the object touches the waves, it reflects like an echo waveform and the receiver receives the target. Only a small portion of the transmitted energy is re-radiated back to the radar, which is then amplified, then converted and processed. The small echo will goes through amplified and down converted and processed to give output. History of radar sensor. Radar has been used in many object detections since the early 20th century. Harnessing the capability to assess the speed of cars was a natural evolution in the use of radar. Mainly, this radar is used in for detecting speed sensors in cities. It is mainly used by traffic police who are crossing the speed limits. Who are crossing the speed limits. They will catch by using radar speed sensor. Using radar speed sensors. The electromagnetic waves can be detected using radar. The name evolved in 1941 as an acronym that stood for radio detection and ranging. The acronym for radar is radio detection and ranging. The name itself known as ranging and detection shows meaning of radar sensor. Essentially, a radar transmitter emits radio waves. These waves travel at a fixed rate through the air until they strike a target or an object. The waves are then bounced or reflected back from the target to a radar receiver, where it shows the location and speed of the object. Up to the range it goes. Whenever the radio waves, it's already predefined that the radar is predefined within certain limit range. Whenever the object touches up to that speed, up to that range, we can calculate the speed from the waves. Radar was originally developed by the military, but today it has many pastime uses, including meteorology, air traffic control, oceanography, and many applications. And this is called first starting using radar for speed sensing device. Speed sensing device. Here it produces radar waves. Whenever it strikes, the complete process is done in inside and produce the speed in monitor. And this is called a police radar gun. Radar guns emerged in the 1950s, used by police to monitor highway speeds. A police radar can accurately report the speed of a vehicle by measuring the time it takes for the radar signal to bounce off your car and return to the radar gun. At a certain time, the radar signals touches the object. Through this time, the speed will be calculated. And the radar detector. In early 1970s, one frustrated motorist, Dale Smith Dayton, Ohio, invented a device that would give drivers an alert if any radar systems were targeting their vehicle. This is the main principle behind for inventing blind spot monitoring system. He invented a device which detects radar sensors and giving signal to the driver. He came up with auto radar detector. After that, he came up with the auto radar detector. The first device, called a fuzz buster, detected radio signals sent out on the band of police radar guns. It gave off high-pitched sound and lit up when these waves are detected. Whenever the radar waves are observed with the radar detector, immediately it goes and gives a signal to the object and with high sound object and light up with these waves whenever these waves are detected. components of a radar. Gen- general, Generally, we are using pulse radar detector, pulse radar systems. Pulse radar systems can be functionally divided into 6 essential components as shown in figure. As shown in figure, first here duplex system, it receives signal from power supply to signalizer and transmitter to duplex and receiver to an indicator. These all components we will discuss in after slides. What is meant by transmitter and what is meant by receiver, synchronizer, indicator, and what is duplex system. Synchronizer. Synchronizer is referred to as timer or keyer. It supplies the synchronizing signals that time the transmitter pulses, the indicator, and other associated circuits. It gives signals within the time to the associate with the related circuits. And the transmitter. The transmitter generates an electromagnetic energy in the form of short, powerful pulses. These are called as waves, electromagnetic waves. And the duplexer allows the same antenna to be used for transmitting and receiving. And the antenna system, it routes the electromagnetic energy from the transmitter and radiates it in a highly directional beam, receives any returning echoes, and routes those echoes to the receiver. This antenna system is the main component which receives radar signals and echoes and separates and give the signified signals to receiver. The receiver amplifies. What is the function of receiver here is the receiver amplifies the weak electromagnetic pulses returned from the reflected object. Whenever here the antenna system takes the signals and sent to the receiver. Here the receiver receives the signals and it amplifies the weakened electromagnetic pulses returned from the reflecting object and reproduces them as a video pulses that are sent to the indicator, or as a video pulses or an audio pulses that are sent to the indicator to indicate the object. The indicator produces a visual indication of the echo pulse in a manner that at a minimum functions range and bearing information. Instead of these video pulses, we can use audio pulses also. The actual radar set may have several of these functional components within physical unit, or a single of these functions may require several physical units. These are not every sensor. There are many radar sensors are available. The basic principle, the working is based on receiver, transmitter, synchronizer, duplexer, and antenna. However, the functional block diagram of basic radar set may be used to analyze the operation of almost any radar set. BSM is known as blind spot monitoring. Here you can watch Here you can see the video of blind spot monitoring sensor using radar sensors. The application which is available. Here they use radio wave sensor, and here the radio waves are signal. Whenever the object enters into the signal, it indicates. And this is the range of the radar sensor up to this range. Whenever the car enters into a blind spot area, it gives signals to the indicator. Whenever it reaches to the blind spot area, it gives continuous signal to indicate in the driver. Here, the signal does not give alert, only it receives signals. And in reverse, here the radio electromagnetic is produced. Whenever the object is entered into the object, it gives signal. This is very useful for parking sensors and reverse control. And this is done by this application is done in Volvo S80 sedan, I already said. Now the second working, which is known as image detector cameras. Instead of electromagnetic waves, here they used cameras for detecting blind spot areas, and the output should be in visible format. What is known as real-time image processing? To extract information outside the world in real time is called real-time image processing. From the outside the world through its visual appearance. Processing the video signals instantaneous which have been taken at real time itself is called real-time image processing. And here we can show working of need for real-time image processing. Why we need this real-time image processing? It produces high resolution, high frame rate video input, low latency video input, low latency operating system scheduling, and high processing performance. If you see in image here, these all are real-time image processing, works under real-time image processing systems. There is a wireless sensor here, and there is an access point here, contact. Whenever any object is there, it gives signals on the spot itself. Real-time image processing. How the signals passes from camera and gives outputs as a video signals. Here you can see the camera receives the signals and it converts the analog to digital through ADC, analog digital converter, and it sends the signals to bus drive, data bus, and the data bus sends the signals to software and driver and RTIP, and finally it gives them by receiver transmitter input. The video signals will be displayed through display unit. In real-time image processing, hardware selection and software performance is both are very crucial. Here we can see working of real-time image processing with cameras. Here you can observe that in this image, the manufacturer of Honda uses a camera in left and right side mirrors to detect object in real time and give signal as a video output signal. And you can observe this practical through this video.
Before there was a blind spot, then there was a beep. Now there's a hidden camera in the passenger side mirror. In a market first, the Honda Accord.
Here the camera produces signals
uses the eye
up to the watt
to show
range.
the driver almost 4 times the view, as well as giving car length markers. What does this mean? Simply, it gives you the confidence to switch lanes easily and safely. Beep. Now there's a hidden camera in the passenger side mirror.
Here, this camera produces predefined range, and you can observe here waves up to what is up the range of cameras, and we can see the range through visual output.
In a market first, the Honda Accord's lane watch camera uses the ID display.
Here you can observe the red line and red lines. This is the indication, and he was also watching, and it is also recording the lanes, and whenever it is very near to the blind spot area, it will detect and alert to the driver. This is the main application, works under real-time image process. And finally, applications of the real-time image processing. It is used in application of blind spot monitoring sensor. This sensor is used in car left and right side mirrors. It also acts as a rear view sensor for detecting object in reverse mode condition. This principle is used for direction of flights, and the radio waves. If we increase the radio waves range, we can detect. This application is used for finding aircrafts where to land, and it gives signals through radio waves. And the principle is used in many applications for detecting objects. Finally, advantages and disadvantages. Through this class, what are the advantages and disadvantages we can know. The first advantage is it is a high level of safety. By using this sensor, you can change the lanes in highway very peaceful manner. Decline in truckload and car body damage. And it also reduces decline truckload. Whenever the truck enters, it gives signals, so we can observe, and safe lane changing in the city as well as on the highway, and provide reliable information on vehicles in the blind spot. And disadvantages. The main disadvantages in this is creating sensor problem. Why it's creating sensor problem means whenever the car collide with other vehicle, the sensor will damage or mechanical problems will occur. We have to replace complete sensor kit. Due to dirt, snow, mud, and miscellaneous debris can build up on blind spot object detection sensors, preventing proper orientation of the system. Due to environmental conditions, it will form a layer on the sensor since it have to produce electromagnetic waves. Due to this dust and dirt, the range will be reduced, and it will not clearly use perfect radio signals. Blind spot sensor or detector only intended to assist the driver when driving, but it cannot replace actual or careful driving practices. You have to take care in driving conditions. It just indicates object is there, and it does not take any action without our response. And the sensor problem overcome with one manufacturing car company known as Cadillac. They invented a blind spot failure system. Whenever any dust or snow appeared in blind spot, it will detect and sends the signal, indicates the driver to clean the mirrors. Or sensors. They used an assist known as blind spot failure assistant. By using this one, we can eliminate this disadvantage. And here we can view signal when indicator sound. It's not only work. It's not only produce signals. It will also give when we want to change the lane. It will give indication, and it will stop the indicator. They use a visual displaying mirror itself. Here, these our car, and this is an upcoming car which is ready to overtake. Whenever the car enters into the blind spot, it will detect and produce signals. It's not only produce here signals, and it gives indication to driver by alerting with LED blinks. This left side and this right side. Whenever indicators on, whenever the car can, it will indicates that it will indicates. We can control this indicator sound by using a switch which is provided by manufacturer. Whenever we want to change the lane, we will give signal by using indicator. When the indicator is on, it gives signal sound. Otherwise, it simply shows the car is crossed behind you. Just it shows signal, and it does not indicate with audible sound. Whenever indicator is on, it will show signal. That is you have to observe in this video. See, now there is no sound because she is not ready to change. Here the driver is not ready to change the lane. So whenever the object is came, it gives just a signal view, but it does not indicate any sound. This is the practical application of using blind spot monitoring sensor. Here you can observe in the mirror. Finally, conclusion. Through this slide, I am concluding the blind spot monitoring sensor. The blind spot object detection systems will improve the comfort and safety of the driver. The blind spot system can warn the driver about the presence of other vehicles in the blind spot area, thus providing an assistance in safe lane change and overtaking. And it does not activate any action with the presence of driver. It just indicates to the driver. The anticipation of vehicles in the blind spot of the driver is provided in a range of some 20 meters, whereas the range of 20 meters is used in small lightweight motor vehicles, whereas in other applications, for example aircraft, the altitude is very high. They can use large range sensors, 500 meters, and also this application is used in marine. These are used in large range of radar sensors. The device will notify the driver of any obstacles present in the blind spot. Unless when the object enters into the blind spot, the system will activate and it gives the signals to the driver. The device will only notify the driver when the turn signal is activated and an object is present. In the turn indicator is an off condition, it shows the vehicle is coming and does not indicates and does not produce any sound signals to the driver. But it shows a notification in display in mirror itself or in a visual display. While using an image processing system, the indication will be shown in video display, LCD screen, in LCD screen. It provides another element safety for vehicle occupants for reducing accidents due to a small reason in highways. And finally, the maintenance should require to work properly in application. Otherwise, it creates many problems. Without proper maintenance, we cannot use blind spot monitoring sensor in real life applications. Reference. Through this reference, you can know about all things. What is blind spot monitoring sensor and different car companies using different type of radar sensors and its application, advantages, all the things you can know through this online car journal. It explains the blind spot monitor sensor system features and its activation, operation, and type of radar sensors like radar sensor or real-time image processing systems and how it indicates the driver through video signals or audible signals or visual display. These all things, and also and how they identify the blind spot area, the driver alert signals, and the sensor problems, and how to overcome the sensor problems. Are available through this reference online journal. Through this slide, I am closing my video lecture. If any queries, you can contact through my mail ID, which is present in this video lecture in the slide. Finally, I want to convey my thanks to my ma'am to present a seminar on this topic. Thank you, ma'am. Thank you for all. for viewing this video lecture.